Hello, welcome back. The title here is called Dividing Terms with Exponents. This is part 1. Here we're going to have a numerator of a fraction that involves something to a power or an exponent, and then we're going to divide that by some other term with an exponent, and we're going to see what to do. I'll give you a little bit of a spoiler alert. In the past, when we multiplied terms with exponents, we added the exponents. Here, when we're dividing terms with exponents, we're going to end up subtracting those exponents. So they are very much a mirror image of what you already have learned. So let's take it one step at a time. The problem that we want to learn how to solve is x squared divided by x, right? Now, a better way to write this, usually we don't write the division symbol like this in algebra. Usually we write it as x squared divided by x. These mean the same thing. In algebra, we usually write it like this. We don't write that division symbol. Now, before we actually do anything, I want to go back and talk about numbers a little bit because everybody understands numbers, right? What if you have something like 2 times 4 in the numerator of a fraction and then divide by 2, right? How would we do it with order of operations? Well, you would say, well, I have to do the numerator of the fraction first before anything else. So 2 times 4 would be 8, and then I would divide by 2, and 8 divided by 2 would be 4, and this would be the final answer. All right, now let's do it another way. Let's write it again, 2 times 4, and then divide by 2. We know that the answer is 4, but what's going on here? You see, you have this 4, and then you multiply by 2, but then you immediately divide by 2. You see, you multiply by 2 and then divide by 2. The 2's seem to cancel out or kind of like undo each other because it's like adding 5 to something and then immediately subtracting 5. You're going to get back what you started with. If I multiply something by 2 and then immediately take the result and divide it by 2, then the multiplying and the dividing by 2 they cancel and you get back what you started with because you're like undoing what you just did. And so you multiply 4 by 2 and then immediately divide by 2, you see the answer we get back is just the 4 because the multiplying and the dividing kind of undo each other. Another way of thinking about that is when you have something multiplied and then something divided and you have like a fraction bar like this, when you have 2 on the top and 2 on the bottom, you already know that, if I go over here, you already know that 2 over 2, 2 divided by 2 is just 1. Anything on the top and bottom of a fraction is 1. So even though there's this times 4 up here, you can just look at the 2's and you could recognize that the 2 on the top and the 2 on the bottom are going to cancel because the 2 can be divided by 2 ahead of time, just giving you 1. And so poof, they kind of disappeared. They're really dividing away and giving you 1. And so what you're really left over with is just the number 4. So the long way of doing it, the way we do it before, is by actually doing the math and we get to 4. But then we start to realize, hey, if I multiply by 2 and then divide by the same number, it's like these numbers don't matter and they cancel away. Another way of looking at it is they divide away. 2 divided by 2 is 1, and then of course 4 times 1, and the 1 doesn't do anything. And so I'm left with what I've started with. So the bottom line is when you have things multiplied together in the top and the bottom of a fraction, if you have anything common in the top and the bottom, you can just strike through them and cancel them because essentially they are dividing away and they're disappearing, not because of magic, but because you're dividing them away and they just are giving 1, right? Let me give you one more example with numbers before we go back to our algebra here. Another example with numbers a little more complex would be 2 times 3 times 3. That's in the top of a fraction, and then 3 times 3 in the bottom. Now, if we do it the long way, we multiply everything in the top. 2 times 3 is 6, and then 6 times 3 is 18. And then in the bottom, 3 times 3 is 9, and we all know that 18 divided by 9 is 2. And so we know the answer to this thing is 2. But let me rewrite the problem again. 2 times 3 times 3 divided by 3 times 3. You see what's happening here? Basically, you start with 2, and then you multiply by 3 and multiply by 3 again, but then you divide by 3 and divide by 3. So it's like the multiplying of the 3's is exactly canceled because you just immediately turn around and divide by the same number of 3's. So you can think of it as basically this 3 is canceling with this one, and this 3 is canceling with this one. And look at what you're left with, just the number 2, which is what we calculated using the long way. So in math, when we're dealing with letters, which are variables, we can do the same process. If you have stuff in the top of a fraction, when everything's multiplied like this, that's the thing, it has to be multiplied like this, and you have things multiplied together in the bottom, if you see anything common to the top and the bottom, then you could just strike through them. Because what's really happening is you're thinking like 3 divided by 3 is 1, and that makes it disappear, and then 3 divided by this 3 is another 1, and then it disappears, and all you have left is what you started with. Now let's go back to our problem. Our problem looks scarier, but it's not, because when you think about it, on the top, what do you have? X squared is x times x. And on the bottom, you just have x. So what's going to happen here? You start with x, you multiply by x, and you immediately divide by x. So these x's don't really do anything because you multiplied by an x, and then you divided by an x. Remember, x can be a number. It'd be like multiplying by 2 and dividing by 2. So you see, I have the same thing, one of these x's in the numerator, and also one of these x's in the denominator. And they cancel each other away. You can think of them dividing away, giving you 1, and the only thing you have left is a single x, and so that is the answer to the question. So if I have x squared and divide by x, I get an answer of x back. That is the simplified form. This value, this variable, has the same meaning as what we've written here. For any value of x I put in, I'm going to calculate something and I'll get the same value over here that I put in over here because these are equivalent expressions, but this one is simpler. All right, I want to get maximum mileage out of this problem. Remember, I told you that in the previous lesson, if you're multiplying terms with exponents and you have the same base, you can just add those exponents. Let's review that for a second, right? If you had, for instance, a to the 2 power multiplied by a to the 3 power, it's the same base, right? And we write all the variables out and we can just add those exponents, a to the power of 5 because it's 2 plus 3. So when we multiply things, we can combine those exponents with addition. What do you think is going to happen if we divide those things instead of multiplying them? Instead of adding the exponents, we're going to subtract the exponents. So what do you have here is you have x squared over x, right? And we're canceling these things, but you can also think about it as x, and you can have the numerator minus the denominator, 2 minus 1. Instead of adding the exponents, subtract them. Remember, this is an exponent of 1. So 2 minus 1 is x to the 1 power, which is just simply x. So when you multiply things with exponents with the same base, you can add the exponents together. We've practiced that. When you divide the same base here with exponents, you can just subtract the exponents and you get the correct answer without going through and doing the cancellation business. And again, I told you, maximum mileage. I'm going to give maximum mileage by working this problem yet another way. What about x squared over x? Same exact problem. Now, I wrote it out in the top as x times x, but in your mind, I want you to remember that this means x times x. And on the bottom, there's a single x. So on the top, there's like 2 x's multiplied together, and on the bottom, there's only 1. So instead of writing the whole thing out every time, instead of doing that, you just recognize that one of these x's will cancel with one of these x's, and I'll replace this exponent with only 1 left, because one of the x's canceled with one of the ones. There's 2 of them here. It's x times x. But I can strike through this exponent and give me and reveal just 1 less because I've canceled. And so it's x to the 1st power, which is x. It's really important for you to understand all 3 ways of thinking about this. This is the full-blown way of writing it all out and canceling. That's what we're physically doing. Or you can think about it as instead of multiplying exponents and adding the exponents, you're dividing these terms and subtracting the exponents. That gives you the correct answer. And finally, you can think about it as here we had x squared. We strike through the single x on the bottom, cancel one of the x's up above because that's what we're doing here, and we're left with x to the 1st power. In the beginning, I'm going to write things out more, but in the end, we're really going to do this mostly. So let's go and let's solve some more problems. And in the beginning, I promise it's going to be a little cumbersome, but we're going to have to do things several different ways. Let's say we have y to the 3rd power divided by y. Now, again, there's multiple ways of thinking about it. Let me rewrite it. I'm going to show you the way that I actually solve this when I actually do it, like in real life, because that's what you have to remember. This y cubed is y times y times y, and then there's another y on the bottom. So the y that we have common to the bottom and to the top, we can cancel. So this 3 must then become a 2 because I've canceled with one of the 3 y's that I had. So all that's left is what? On the top, y squared, and on the bottom, when you strike through it, it's like there's a 1 left over. And so you can put a division bar with a 1 if you want, but it doesn't do anything. The only thing you have left is y squared, and that's the final answer. But because we're learning, let's go ahead and work it a different way. Y cubed can be thought of as y times y times y, and on the bottom, you just have a single y. And as we said, anything in common to the top and bottom, you cancel it. And what do you have left? Y squared. This is why what you're doing works, because when you replace the exponent, you're canceling one of the ones on the top with what's on the bottom. When you have things that are common to the top and the bottom of a fraction, you can just strike through and cancel them because they're dividing away and they're basically revealing a 1. And then the last thing I will say is if we remember, these are divided and we have the same base. So instead of adding the exponents, we can subtract them. 3 minus 1, there's an exponent of 1, is 2. And so the answer is y squared. So 3 ways of thinking about it. Blowing it out and canceling. Just subtracting the exponents, 3 minus 1 means y squared is the answer, or just striking through and canceling with one of the exponents, revealing one less. All right? And we have to think about all 3 ways of doing that, unfortunately, in the beginning. What about b over b squared? Let me rewrite it before I strike through anything. So I have a single b on the top, and I have 2 of these b's on the bottom. B times b, that's what that means. So if I can cancel things out on top and the bottom, I have a single b that will cancel with only one of them down here, revealing one less b on the bottom. Remember, when you cancel these terms, then you're really revealing, it's like there's a 1 left over, because what you're really doing is dividing b divided by b. So on the top, you're really going to have a 1 left over, and on the bottom, it'll be b to the first power, which is just 1 over b. Right? The same thing happened here. I could have written this in this step as y squared over 1, because when I struck through that, it reveals a 1, but anything divided by 1 is just the number, the thing itself. So it doesn't matter when it's like this, but when you reveal a 1 on the top, you definitely have to write it. Now let's blow the thing out and do it a different way. What you will have is b divided by b times b. 2 b's on the bottom. So what you have is one of these b's canceling with this one. Again, when you cancel, you're like revealing a 1. They're dividing away. B divided by b is 1. So there's a 1 here. And on the bottom, the only thing left is b. Same answer. Now here is the bonus question. Here is something that you probably won't learn until much later in math. But I taught you that when you're dividing things with the same base, you can subtract the exponents. 2 minus 1 means x to the first power is the answer, right? And then we did another problem where we had the same base, and we can subtract the exponents. 3 minus 1 is 2, so it's y to the second power. But what happens here if, let me just work the problem another way over here. If it's b over b squared, it's the same base, I can subtract them. B, I have a numerator of 1 minus 2. Now this looks a little bit weird. What is 1 minus 2? 1 minus 2 is what? Negative 1. So what you actually have here is what we have called a negative exponent. And you're saying, whoa, is that even possible to have a negative exponent? This is not a lesson in negative exponents, but yes, you can have a negative exponent. And the definition of a negative exponent is just to move the thing downstairs and make the exponent positive. That's what a negative exponent is. When you have an negative exponent, it means move it downstairs and make it positive. This is the definition of what a negative exponent is. So even if you subtract them, you'll just get a negative exponent and you will get the same answer as we calculated in all the other ways. So I guess what I'm trying to say is when you're solving these, you can subtract those exponents, no problem. If you get a negative one, then that means you move it downstairs, make it positive. Or you can write the whole thing out and cancel everything. Or you can just cancel like we did in the beginning here, where you're striking through part and making the exponent 1 less. In any of those ways is a perfectly fine way of thinking about it. All right, again, I did a lot of talking in the beginning. Let's take a look at x to the 5th divided by x to the 3rd. Let me rewrite, because I'm going to do it the way I typically do it on my paper, because I want to teach you, I think, the best way of doing it. So you see what we have here is 5 x's multiplied on the top and 3 x's on the bottom. So since I have 3 of them on the bottom, I'm going to strike through all of the x and the 3, canceling everything down here. 3 x's will cancel with 3 on the top, revealing 2 left over. You see what I'm doing? I'm just subtracting 5 minus 3 and I'm getting 2. That's what I'm doing. I keep telling you you can subtract the exponents, but that's all you're doing when you cancel, because you're saying 3 of them are gone, and so 5 minus 3 is 2. And so the answer is x squared on the top, and you reveal kind of a 1 down here, which just does nothing, and so really the answer is x squared, and that is the final answer. If you didn't do it this way and said, well, I'm dividing, I'm just going to subtract the exponents, 5 minus 3 is 2, and so the answer is x squared. And this will be the last time I write it all out, but what we had here is x times x times x times x times x. There's 5 of them. And then on the bottom I had 3 of them, x times x times x. So when we cancel this on the bottom with 3 on the top, we're canceling 1 pair of x's, 2 pairs of x's, 3 pairs of x's. They all divide away to give us 1, and all you have left is x times x, which is x squared. Usually we do not write this whole thing out. I'm doing it so you'll understand what we're doing. Usually you strike through. When I'm canceling all of the x's, I'll go through the whole thing, and just notice I only strike through the exponent up here, revealing x to the power of 2 left behind. All right. Let's take a look at, and notice that 5 minus 3 is 2, so you could do it that way as well. What about a squared, a to the 6th power? Let's rewrite it before I strike through anything. Now, before we do anything, these are divided. So instead of adding the exponents, you could subtract them. So before you do anything else, 2 minus 6, let's just write the answer over here. A to the power of 2 minus 6. You could subtract them. What is 2 minus 6? A to the power of -4. 2 minus 6 is -4. So you get a negative exponent. Now, put that aside for a second. How would we do it the way that I actually prefer you to do it? Well, I have 2 a's on the top, and I'm going to cancel both of those a's with 2 of them on the bottom, revealing 4 left behind. And so on the top, I'm going to have, when you cancel through, you have a 1, and on the bottom, a to the power of 4. Notice 1 over a to the 4th is exactly what I told you this is. Because a negative exponent is the definition of what it is moving it to the bottom and making it positive. So just doing the subtraction gives you the same answer is what you get manually. Now this really is the last time I'm going to blow it out here. I said I wouldn't do it, but I feel the need to do it this last time. 2 a's on the top, 1, 2, 3, 4, 5, and 6 on the bottom. All right, so what do we have? Cancel, 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 cancel. I have 4 a's on the bottom, a to the 4th. What do I have on the top? You cancel them, but you're really revealing a 1 left behind because this divides to give me 1, this divides to give me 1, 1 over a to the power of 4. So going forward, either subtract the things or cancel through the way I'm showing you here. That's the way we're going to do it going forward. All right. We'll take a look at number 6, which is 2 times y to the power of 3 divided by y. All right, now notice the only difference here is we have a number involved. So I guess I lied a little bit. I said I wouldn't blow it out for you, but here in the beginning we're learning. Let's go ahead and just do it the long way. 2y, another y, and a third y. Here we have a single y on the bottom. So what do you think is going to happen? Well, one of these y's cancels. What do you have left? 2 times y. That's just 2y squared. You really have a 1 on the bottom, but that 1 on the bottom doesn't do anything, so that's the final answer. If I were to do it with cancellation, kind of like not the long way, what would I do? I would recognize that I have a single y on the bottom and 3 of them on the top. So this one will cancel with 1 of them, leaving 2 left over. So I would have 2y squared left over, which is exactly what I got. All right. Now what do I have for the next problem? 3 times b to the 4th divided by 6b cubed. All right, now this is interesting. What do I do here? There's lots of different ways to think about how to do this. I do think it is going to be easier if I blow this thing out. 3, and then I have b, 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 and b. And then over here I have 6, and then 3 b's. All right, the b's are easy because they're the same thing on the top and the bottom, right? B cancels, B cancels, B cancels. But what do I do with the numbers? So this is how it comes all full circle. We have to know fractions. We learned fractions a long time ago. You learn that anytime you have a fraction, you can simplify by dividing the top and the bottom by the same number. I have a 3 and a 6, so I can divide the top and bottom by 3. 3 divided by 3 is 1, and you just literally strike through and replace it. 6 divided by 3 is 2. So these numbers reduce to 1/2, and all of the b's canceled except for only one of them, right? But on the top, you have a 1, and everything else canceled except for the b. So 1 times b is b, and on the bottom 2 is the only thing you had. So b over 2 is what you get, right? B over 2 is what you get. Now, if you don't write it all out the way we've done it here, whoops, it looks like I messed it up, sorry about that. If you don't write it all out, 3b to the 4th power over 6b to the 3rd power. Let me rewrite it. 3b to the 4th, 6b to the 3rd. Let me show you how I would mark it up on my paper. I would say I have 3 b's on the bottom. All 3 of them are going to cancel with 3 of them here, leaving behind only 1 b. And then I have these numbers, and I'll just do fraction simplification. 3 divided by 3 is 1, 6 divided by 3 is 2, and I'll strike through and put them there. And then on the top, I have a 1 times b to the first power. That's just b. And 2 is the only thing left on the bottom. So I don't have to write it all out. Once I get used to marking it up like this, then that's what I'm going to do going forward. The very last thing I will say is our original problem statement had b to the fourth and b squared. You could do it by subtraction. Same base, 4 minus 3 is 1. So b to the first power, that's why that's up here. And then this reduces to 2 on the bottom, just like this. Same thing before. When we had this, you could do it by subtraction. 3 minus 1 is y squared. The 2 just comes along into the answer. So you can think about it as subtracting exponents, or you can think about it as canceling. All right, we only have 3 more problems. What about negative 4 x cubed over 6x? I'm going to rewrite it before I mark it up. Negative 4x cubed over 6x. Now, the way I like to think about these is to think about canceling. I have a single x here, and I have 3 of them multiplied here. So this single x will cancel with one of them, leaving 2 behind. And then I have this fraction here, which is a 4 on the top and a 6 on the bottom. Forget about that negative sign. I can divide by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. I'm just dividing top and bottom by the same thing. And then when I write my final answer, I have a negative 2, and I have an x squared. And on the bottom, I have a 3, and that's all that's left. So the answer is negative 2 on the top, x squared on the top, 3 on the bottom. And if you think about it as subtracting exponents, 3 minus 1 is 2, so x squared, that's why it's on the top. And then this reduces, the negative sign stays there, this reduces to 2/3, which is what I have here. Basically, positive exponents are on the top of the fraction, and any negative exponent you ever get, you just move it down to the bottom of the fraction and make it positive. That's something you learn later, but I just can't resist telling it to you now because it's so easy to understand. When you multiply things with exponents and you have the same base, you can add the exponents. When you divide things that have the same base, you can subtract the exponents. And if you ever get a negative exponent, that's okay. It just moves downstairs. So the same rule applies. It's not like a different rule or a new rule. It's something that always works. All right, 2 more problems. We have 8 times a squared over 10a to the fourth. All right, I'm going to rewrite it before I mark it up. 8a squared, 10a to the fourth. Now, as far as the exponents, I have 2 a's on the top. I'm going to cancel both of them with only 2 of them on the bottom, leaving 2 behind. And then, for the numbers, I can divide top and bottom by 2, right? 8 divided by 2 is 4, and 10 divided by 2 is 5. And so on the top, I have a 4, and there's nothing else left. I've struck through everything else, so it's just a 4. And on the bottom, I have a 5, but I also have an a to the power of 2. Notice how when I'm striking through the entire thing, I go through the variable and the number, but when I'm leaving the variable and I'm just changing the exponent, I just strike through the number. So it's 4 over 5a squared. That's the final answer. Now, if you want to think about it in terms of subtracting exponents, same base, subtract 2 minus 4. What do you get? 2 minus 4 is what? A to the negative 2. That means it moves downstairs and becomes a squared, and then the fraction, 8/10, becomes 4/5. So that's how you can get to the same place by subtracting exponents if you prefer to do that. Here's our final problem, negative 12y over 15y to the fifth. Okay? Let's rewrite it, negative 12y over 15y to the fifth. Just to do something different, let's do it with subtracting these exponents here. Let's work with the numbers first. I can divide by 3. 12 divided by 3 is 4, and 15 divided by 3 is 5. And then I'm just going to subtract the exponents here. I'm not going to cancel anything, just to show you a new way of doing it. On the top, you'll have a negative 4, and on the bottom, you'll have this 5. But then, what is 1 minus 5? 1 minus 5. That's going to be y to the 1 minus 5. I'll just write it out, I guess. And so on the top here, you have negative 4y to the negative 4. 1 minus 5 is negative 4. And what happens when you have a negative exponent? You just move it downstairs. That's what a negative exponent is. Negative 4 on the top. Move this whole thing downstairs and make it positive. So negative 4 and then 5y to the positive fourth power. That is the answer. That's what you would do if you were subtracting. You would get a negative exponent, and then you would have to move it downstairs. But because I don't really love doing that, I would like to rework this the other way. 15y to the 5th. The numbers, everything stays the same. 12 divided by 3 is 4, 15 divided by 3 is 5. And then for the letters, I have a single y upstairs that will cancel with one of these, revealing 4 left behind. On the top, you'll just have -4. On the bottom, you'll have a 5y to the 4th power, which is what we have left behind here. You'll get exactly the same thing as you get if you were to subtract those exponents. So here we really have covered a tremendous amount of material, and it will be very useful as we go forward. You will use these concepts forever. The idea is when you have something on the top divided by something on the bottom of a fraction, you can simplify the numbers like we always do with fractions. We can divide top and bottom by whatever we want. But when we have these variables, any variable on the top can be canceled with any variable on the bottom. And that is exactly the same way of thinking about subtracting the exponents. Because notice before, when I subtract 3 minus 1, I got an x squared. But if I ever subtract and I get a negative exponent, like this, then it means it just floats downstairs, because a negative exponent, that's like a new thing I'm teaching you here. A negative exponent just goes into the denominator. That is the definition of what a negative exponent is. A lot of students say, what does a negative exponent mean? That is what it means. It means you move it down to the bottom. That is definitionally what a negative exponent means. So when you're canceling these and thinking about them, you can think about subtracting the exponents, or you can think about canceling all the blown out terms, or you could just cancel, like I've been doing, variables with portions of the exponent downstairs. This is the way I actually like to solve the problems. You might find your own way. Everybody has different ways of thinking about this that you're comfortable with. So solve these yourself. When you feel that you have it upstairs in your brain, you're getting the right answers, follow me on to part 2. We'll actually crank up the complexity a little more in part 2 of dividing terms with exponents.